a couple more questions for you too that I'm not sure if you can answer, but we can find out.
Okay.
um, okay, so the first question for you is, I just wanted to make sure, since the questions are kind of vague at points, on parts B and C of problems 1, 2, and 3, those are all context dependent, right? At
Yes.
least for the second parts. So like, um, if we're dealing with the second example where it's that triangle of triangles, parts B would be let me see here. I guess C is the better example. But when it says for problem 1, it says how many distinct 9 colorings of the edges are there, and then how many of these colorings consist of distinct colors. So for problems
Yes.
2 and 3, that context switches right to whatever the number of M colorings of vertices are in problem 2, or the M colorings of faces in problem 3, right?
Right. Hmm.
And then when you ask if how many distinct colorings there are, those are of the problem 2 things or the problem 3 things, not of edges in problem 1, right?
That's right.
Okay, gotcha.
So whatever the original object is I'm asking you to color, I'm asking you for color for the number of distinct colorings with distinct colors for that whatever that first object is I said to color. Yeah.
And then um, I'm going to go ahead and ask you these other questions. My hesitancy is mainly because I know you normally upload this to YouTube, and my questions might give away some of my approaches for solving the problems, but I guess you can choose whether or not you want to cut it out and not upload it.
Okay. Okay.
Yeah, I'll leave that in your hands. But so to me, the trickiest thing on the exam has been part C of 1, 2, 3, and then leading into 4.
Hmm.
I think I figured it out last night, but what I ended up doing was using the Polya pattern inventory. At least that's where I started on 1, 2, and 3C. But Wolfram Alpha was only able to handle it. Like I did the whole thing, and Wolfram Alpha was only able to expand the second one. And then I solved that by inspection. Like, oh, okay, just look for this term where each thing's
Yeah.
only once.
Right. So what I'll say, and I mean I've said this to others like in email, so it's not that big of a deal. Like you don't have to put all the terms in Wolfram Alpha.
Right.
Only those that obviously contribute
Mm-hmm.
to the
And
term.
that's what I figured out last night. I was
Yeah.
like, wait a second. So I tried that.
It's like obviously this one isn't going to contribute to the coefficient of, A, B, C, D, E, F, G, or whatever it is
Right.
you're looking for, right?
So once I revised that, I tried it again on Wolfram Alpha with problems 1 and 3 because those were larger expressions. And it still couldn't do it. It says it timed out.
Hmm.
And so I tried Maple instead, and that worked on problem 1, just doing what I thought was the relevant portion. And it still ended up being a lot of terms. And thankfully, Maple put them at the beginning. So that's how I found the coefficient for that one. And then for number 3, I ended up using the multinomial theorem
Yeah, that might work.
to find the coefficients for that one piece that I thought would be it. So I just wanted to make sure that is that okay that I use 3 different methods for the 3 different problems based on their
Sure,
size?
yeah, of course. I just wanted you to find it. And then ultimately, the fourth problem,
Right.
like that's just kind of trying to say, hey, you could have just thought about this, right? Or something, right?
Yes.
And you could have just counted it, right? I don't know why Wolfram Alpha is unable to expand those simplified things. Maybe you're still including terms that don't need to be included. But I mean, I don't think my machine is that powerful in it.
You don't have the pro version, do you?
No,
There's like a paid subscription to Wolfram Alpha that you can have.
no. But I think
Okay.
this happened once before. You said it wouldn't expand something, and then I did it. Remember, like during office hours, and it just did it.
hmm
So I don't know. That could be part of what's happening. I don't know why. If it's
Okay.
to do with internet connection or what, but
Yeah, I don't know, because the error it was saying was at the top. It looks like it's saying it doesn't understand the input, but I've determined it was clearly just the magnitude of the problem because I could reduce the power on my expression and it would do it just fine. And I scrolled down a little bit and it says like your allotted time has like expired, and then it said try using Pro because you'll have twice the computing time. I'm like, no, I'm not going to pay $5 for that.
yeah. Yeah, I mean, that was intent. I mean, I did that on purpose just because I wanted you to have to think about, what terms actually mattered.
Okay.
But yeah, I'm not sure why I did that. But I mean, there are so many ways that you could compute it
Mm-hmm.
that it seems like you're able to get out of it anyway. Anyway.
Okay. Yeah. So that's
Were
what I
you
ended up doing. And
were you at least getting consistent answers?
I think so, because I started playing around with problem 4 last night, and I'm like, I think I see this. And
Yeah.
my method in problem 4, I think, is correct because I tried it out on the 2 versions that or problems 1 and 2, the ones I did with Maple and Wolfram Alpha, and I got the same answer. I'm like,
Right.
sweet.
Right. There's something right. So there's I mean it's 4A is not intended to be like a super tricky problem, but I think thinking through the first 3 problems, you start to see something and then you go, "Oh man, I think I see what's going on in general here." You know.
Yeah.
So if you have that feeling, then you're probably on the right track.
Okay.
Yeah.
I just wanted to make sure that, like, I was just kind of curious, were you expecting us to use a multinomial theorem on all 3, or did you use Wolfram Alpha on all 3? Once you broke down the chunks to the smaller sizes?
I did it in multiple ways.
Okay,
Um,
that's fine. After the exam is submitted and everything, probably, I don't know. Sometime I'd love to ask you some questions about this, because just from like a curiosity standpoint, there's been a couple things that I'm like, why is this happening?
Yeah. Well, that's cool. That means it's a thought-provoking collection of problems. That's good.
Yep.
Did you have to make a cutout for your dodecahedron?
No, I ended up using a 3D rendering on the internet I found, where you can kind of just like spin it around at will,
Wow.
which is pretty cool.
What's that? Do you have the website for that? I'd be like to see that.
Yeah. Sometime let me try to find that real quick. Sometimes it's not quite as much control over the spin as you would like, because it only lets you drag it from like one point. So
Oh, okay.
like most of the time you can get it to do what you want, but you can't like have complete control over it.
So did I paste in the test the website for where I got the picture?
You did. I think that was Wikipedia, wasn't it?
Oh
no.
Yeah, so that one at least had like a spinning dodecahedron.
Yeah.
Around one axis.
This one was from this website called Sketchfab, and apparently people like create 3D models of things.
Yeah. Yeah, dodecahedron's a pretty cool shape.
Mm-hmm. Oh, actually, I could probably share my screen with you.
Oh, okay.
And show it to you.
Try that out.
Can you see this thing?
That's coming up. Oh, yeah.
So,
oh, man.
That was pretty cool.
Wow. I want to go look at what other things they have.
Yeah, they have like, I don't know, it looks like you can almost see it inside of the Pentagon. or I don't know. There's some pretty cool stuff.
Wowee. I'm gonna have to check that out.
I know, and then yeah, you can zoom in and out and make it bigger or smaller.
Wow. That's way more high tech than my tetra puzzle.
Yep.
So yeah,
Okay.
that's cool.
Yeah. So
Well, I don't know. I think this is really cool stuff. Hopefully you guys got the same feeling, but
yeah, I did. It's like crazy. I did get Maple to do the first, what was it, like 100 terms on the front and back end of the expression of the full thing of the big one, problem 3. And it
Yeah.
said it was like over 1 million terms.
Oh, that is so sweet. I love that. Yeah.
That's how big the pattern inventory is.
Yeah, right. Well, I think the problem is you have so many colors, right?
Yeah, exactly.
12 colors or something.
Mm-hmm.
Yeah. And by the way, I mean, I had a couple people ask me about this. Like, once you have the cycle index polynomial for one of the shapes, like, it wasn't hard for you to get it for the other, or sorry, once you have it for one of the objects you color, like vertices or something, you didn't have to work super hard to find it for edges and faces, did you?
Spent a couple sentences explaining,
Yeah,
but
you basically just had to say, oh, instead of, a permutation of 12 things, it's 9 or something, and the cycle structure changes slightly or
yeah.
something. But you had already done all the thinking, basically, right?
Yeah, at least the first time. Like, it was helpful because I had already thought through applying it for one type of coloring, but I had to just kind of run through it again with the different types of colorings in my head.
Yeah. So, I mean, my hope was just, since we hadn't done a ton of like flipping from coloring vertices to edges to faces, to just let you do that here and see that the process one goes through to do that is fairly straightforward once you've kind of done all the thinking for one of them. Does that make sense?
Yeah,
Yeah.
makes sense. So on the ones where I ended up using Wolfram Alpha or Maple, I just kind of wanted to make sure that my explanation was good enough. And I basically, at those points where I use those programs, just said like, here's the unexpanded form of the Polya pattern inventory. And then I said like, by expanding this and inspecting it using Wolfram Alpha, this is the coefficient. Is that okay?
Sure. Yeah.
You want-
I mean, I don't want you to write down, 1,000 terms or
Right.
I wasn't even necessarily expecting people. I said you could use Wolfram Alpha, so as such, I wasn't expecting you to do the expansion by hand. Although what my claim is, and you figured this out on one of them, you can do it by hand, which is sort of amazing, right?
Yeah.
You just have to know what terms to expand and what to extract out, and then you go, oh wow, there it is, right there. The multinomial, one reason I wanted to go more into the proof, like in the last lectures, was so that you guys would have a really firm understanding of the multinomial theorem. That's a really, really important theorem. And you can do a ton of stuff with it, including extract abominable looking things from, or actually extract, coefficients from expansions that on their head just look impossible to deal with,
Yeah.
And apparently you did that, right?
But only out of desperation. So you claim that I could have done problem 3 with Wolfram Alpha. Is that what you're saying?
I think so, yeah.
Okay.
I think so. At least as I recall, I think I was able to do it with Wolfram.
Okay. I think I got the answer using the
Yeah.
multinomial theorem, but it's kind of annoying to me that I can't figure out why Wolfram Alpha isn't working. So, like I said, I might have some questions to indulge my curiosity later on, after the exam has been submitted, so that we
Sure,
can actually talk about it.
it's understandable. Yeah. And then 4B, where I asked you to do, did that
And
work?
that one was easy because you only had 3 colorings, so that was very easy for Wolfram Alpha to do.
Yeah, yeah, yeah. That's good. Because you only had 3 colorings. Oh, you mean you only had 3 coloring.
So like M is 3.
Wait a minute. Wasn't there one where I asked you to do how many have 3? I thought I asked something like uh was it 4 each of 3 colors or something? Is that what it was or something? I don't remember.
Yeah, each color is used exactly on exactly 4 faces, but there were only
Yes.
3
Yeah.
color options.
Yeah. So you almost didn't even need Wolfram Alpha to do that.
Probably not.
Wolfram Alpha, but you used it.
I did.
Okay.
Okay. I think that helps.
Was it an enjoyable test?
Um, at points, it was more work than I was expecting. I kind of got to those first 3 problems and I was like, oh, he's wanting us to do all 3 cycle index polynomials.
Mhm.
And then I got a little weirded out when Wolfram Alpha wasn't working, and I was like, is he wanting us to use the multinomial theorem? Because we never had to use it in the homework. But I ended up like teaching myself that and reviewing it based on your lectures.
Mhm.
So I think it worked out. But yeah, other than that, it was a good test.
That's good. I forget what the last problem is. Oh, that was the one on
Work polynomials.
yeah. That worked out all right for you?
Yeah, I was surprised to see that problem on here. When I first opened it, I was like, is this going to be a comprehensive exam? And then I was flipping through, it's like, first one's the same, second one's the same, third one's the same. Oh, I guess he's just doing chapter 9. And then I got to problem 5, and I was like, oh, guess not.
Yeah. I think I asked you a root polynomial question on the last test.
You did, but I don't think it had the removing square thing.
Right, right. So I wanted to give you one where you had to do that.
Mm-hmm.
So, and then there was one where one of the shapes you kind of had to do it a couple times or something.
Yeah, which is interesting.
I told you that, right? I said,
Yep.
you know. Right.
Yep. Oh, cool.
Well, enjoyed having you in the class. What are you taking next semester?
I'm graduating.
Oh, that's right.
Yep.
Man.
Yeah. So I was planning on calling you on Zoom sometime and giving you my official see you later. But since I have more curiosity questions for you about the exam, I figured I would wait to do that for like another week or so.
Right. Well, cool. We appreciated having you. I hope we see you around. Come back. Are you gonna?
Oh yeah. I'll be
Yeah.
back, hopefully for homecoming in the fall. And also I have 2 younger siblings. I go to Cedarville. So if I ever go back to visit them, I'll be around.
All right.
So I'll have to stop by sometime.
Yeah. Well, man, it's been a lot of fun having you in classes.
Yep, I've really enjoyed it. And thank you so much for teaching us with the passion you have for mathematics. It makes it a lot more exciting.
Yeah. Hey, actually, I mean, I'll send it out to you maybe at some point, but I think Dr. Fry and I might write a paper on using Burnside's theorem in the context of number theory. I was thinking about it and I realized using Burnside's theorem, you can prove things like Fermat's little theorem. Do you remember Fermat's little theorem?
It sounds familiar, but I don't remember it.
Yeah. So there's a whole bunch of things I'm been thinking about, and I think you can prove. I mean, what else am I going to do? I'm sitting around in here, right? So there's some cool stuff that you can do with this. You know, if you take the right shape and you color it in the right way and you ask the right question,
Wow.
you can prove some really interesting things. And I hadn't seen them before, so I shot Dr. Fry an email yesterday. I think we're going to think about it. It'd be great.
Cool.
All
Well,
right.
I think I'm going to go ahead and write up my answers to the rest of these problems and get this thing done.
All right.
But thank you for clarifying some stuff for me.
All right. Take care, Logan.
Yep. And I'll reach out again soon. See you
All
later,
right.
Dr. Hammett.
See ya.